Let's check whether this given set here, a set containing 1, is a group under the usual multiplication. So for us to do that, we need to establish the different conditions as well as the preliminary conditions of non-empty and closure property for this set, so that we could decide that this is a group or not. Of course, we have here a unit set, and we also have a Achilles table here. Only one entry to which we are going to perform as well later. So of course, this is non-empty. That's very obvious. It's because we have here an element which is 1. And if we're going to examine the idea of closure property, if we have in usual multiplication, if we have 1 times 1, the result is 1, still an element of G. This means there is closure property for this given set. With this too, we can proceed to the idea of the different conditions. But of course, this result of 1 here can be placed here in our Achilles table. 1 star 1, or in this case 1 times 1, as star is our usual multiplication. I forgot to do that. Let us have it here. Let star be the usual multiplication. So we could also use the idea of star as we go through. So let's have G1. Okay, G1 is the first condition for a group. We're going to examine if star is associative in G. So associativity means we need to establish this given condition. A star B star C is equal to A star B star C, where A, B, and C element of G. But of course, we only have one element, and we know that A is 1, B is 1, C is 1, as they are all elements of G, and G only contains one element, which is 1. But of course, we're going to establish this here for our left hand side. A star B star C. So this is again under usual multiplication. So you have 1 times 1. Okay. Then star 1. This is 1. Star 1 is times 1. We have the result of 1 here for our left hand side. For our right hand side, you have A star B star C. So we have here 1 times 1 still. A star that. But of course, A can be equal to 1 itself. So we have 1 times the result of that, which is 1. So 1 here. Of course, in symbolic form, the left-hand side is just ABC, and the right-hand side is also ABC under usual multiplication. This means that star is associative in G. So G1 is now satisfied. Let's proceed to the next condition, G2. So let me change the color here. So let's have G2. So G2 is the condition for the existence of an identity element. And we already know that the identity element for multiplication or usual multiplication is 1. And 1 is already an element of this set G. Then we can say that this is satisfied. But of course, we're going to show it anyway in symbolic form. So we have here let A be element of G. We're going to find E element of G such that we're doing this so that we could actually practice this one. A star E equal to E star A equal to A for all A element of G. So of course we have here A times E is AE, E times A is EA, to which we could actually rewrite as AE as well. So they are just the same. Okay, so this means any of this or AE is equal to A. And we can solve E here when we divide both sides by A. So we have here E is equal to 1. And this is actually the identity element for usual multiplication. And this is an element of our G. This further shows that our G2 is satisfied. Earlier, just by inspection, we can just say G2 is satisfied because the identity element for usual multiplication, which is 1, is already an element, which is already an element of G. This time, in symbolic form, we further simplified it. Now, let's proceed to the third. Since G2 is satisfied, let's go to G3. This is for the inverse element. So we have let A element of G. We need to find inverse of A, which is also an element of G, such that A star A inverse star A equal to E, which is 1. So we need to show that our inverse element for A, which is A inverse, is also equal to 1, such so that it would be element of G and G3 will be satisfied. Of course, using usual multiplication, that's A and A inverse. This other form here is A inverse A, or by commutative property, A and A inverse. Again, they are just the same. So A inverse is equal to E, which is 1. A times A inverse is just 1, removing E in the picture. And we can just solve our A here, our A inverse, by dividing A on both sides. We will have A inverse be equal to 1 over A. Is this an element of G? That's a big question right now. Take note that our A is just 1 itself. So if we have 1 over 1, or in the other sense, it's just the reciprocal of A, right? So reciprocal of 1 is 1 itself. So that's 1. This is an element of G. This further shows that G3 is also satisfied. With G3 here satisfied, our G2 also satisfied, and associativity earlier was satisfied. We can now say that our set G, which is set containing 1, is a group under usual multiplication, or the star that we represent earlier. So this is the final decision for this. G, which is a set containing 1, is a group under usual multiplication. So this is the answer for this given item. Thank you very much for watching.